Systemics is a French institute of technology. We do applied research with industrial partners. And I'm the co-author of this paper with Afef Awadid. She can't be here, but she's the main author, and she's the one who deserves all the credits. So I'm going to talk about change impact analysis. Change impact analysis, so I will use the acronym CIA. And no joke about the CIA. So analysis of change propagation in terms of criteria, mainly rework. I think the term rework is the main problem we have. And when I try to explain very briefly the problem, I use this image and many people will have an intuition about impact with these three levels of coupling, three association type. So the first intuition about change and impact. I will begin with a problem definition with my perspective, and I will present the solution based on traceability language with proof of concept implementation. It's a work in progress, so we are very conscious of the limits, and the context is system engineering, and we work with different partners. So sometimes it's system engineering with fuzzy diagram, operational design, and sometimes it's more technical. So first problem I want to highlight, delays and risks. For us, CIA is a human-based activity and a committee-based activity. So when human is involved and with a group dynamic, social dynamics, sometimes we will have social problems. In this image, we see in causae level, concept level, functional level, physical level, and requirements, behavior, structure. The point here is to highlight the collaboration between teams with various perspectives. And we have links between all that stuff, allocation links, for example, and allocation links are sometimes defined in Excel file outside the MBC stack. So there is a lot of trouble to maintain the consistency of the global situation and models. So a social process and a risk of errors. And problem number two, traceability per se is not enough, because when the goal is to just maintain traceability links, we don't achieve the goal to master and to analyze impact. So the first approach, we maintain the links and we maintain allocation table. It's not sufficient. So the impact needs to be assessed globally, and in current links, the semantic is not defined to reflect changes. It's association, it's messages. So there is no support to trace changes. So a lot of links, bottom-up changes, top-down changes. So diversity of situation, and changes without digital continuity. So a lot of extraction, import, export between specialty. So missing links are a big problem because coupling sometimes are hidden. So automatic discovery of hidden coupling is a big problem. And we have industry-specific concerns. So we need sometimes a keyword and refinement to check information from specialty engineering to integrate this information at the system level. So we have an approach based on a domain-specific modeling language. At this stage, it's a conceptualization. We have a proof of concept implementation, but it's a conceptualization. And this conceptualization is based on a set of requirements, the identification of the main drivers we want to track. So we call CIA parameters the information we want to track. And we have a first definition of functionalities for tools. So the requirements work is done to separate different usage of the CIA approach. The requirements are classified into two categories. So for the modeling language and for the procedure and the tools we want to build around the modeling language. And the first result is a meta model of the modeling language. So the diagram is composed of two distinct parts. On the top, we have a traceability pattern. And on the bottom, we have an inheritance tree around what we call CIA parameter. So this information is to enrich the modeling views with information with an impact. And here we have traceable elements and relationship in relation, in association with a change, and a system of view and view elements. So the view and view element is to create viewpoints around CIA. Traceable element, it's the bag with all the stuff. And here we have the payload. So CIA parameter, any kind of information that could contribute to quantitative or qualitative change impacts assessment. In the yellow, we have more details about this parameter. We have done this work in a former project, and we have stuff reflecting this former project. So the change nature, it's simple: addition, deletion, update. Level, the problem was very structural problem. So aircraft level, subsystem level, component level. Level here is linked to the structural modeling. The domain in the former project, it was a dual domain problem, architecture and safety. So the consistency problem was to maintain consistency between safety and architecture. And we use the domain attributes to classify with this dual attribute. Phase to track some element of the V cycle. Element type between, because we have a distinction between atomic and composite. Magnitude to track the neighborhood and the number of links involved in each traceable element. Relationship type. So we have a lot of work in the relationship type to make a distinction between allocation, association, cross-domain links. And then we have the traceability relationship semantics, a field for extensibility to store attributes of specialty. So, for example, extensibility with specific domains like specialty, engineering specialty, or subclasses of a relationship. So these concepts are the cornerstone of the language. And with these concepts, we want to construct new views in a modeling procedure. So now we use the CIA language in a process. So we generate traceability graph. So at this stage, it's a dependency graph between the system architecture and a traceability view. So in the current implementation, we only compute the number of elements in a neighborhood using the magnitude parameter. And with this implementation, we generate a dependency graph. So a graph-based notation and the magnitude indicator. This traceability views generation is just a first step, but the goal is to use all the parameters to construct traceability views to create a decision support system. In the introduction, I was using the term change control board because the decision support system is the goal to present information to the change control board. The test implementation is done with ADIO X6. It's a meta-modeling platform. And we have a viewpoint and attributes with values. And we use events in the meta modeling platform to generate events on the architecture side to maintain the consistency on the traceability side. So the paper presents a language, a procedure, and a proof of concept implementation. The central concept is the CI parameters concept, referring to all kinds of information that will contribute to the assessment. The modeling procedure allows creation of view, and the roadmap is on two aspects. So we have a big subject in the setting phase, because discovery of the situation and automatic creation of hidden links is a big goal of the work. So discovery, scripting discovery is a big part. And the parameter usage is the second part of the roadmap to produce the decision supports. So thank you very much. And I'm waiting for your questions.